Morning guys, welcome to today's lesson, April 13th, Intersecting Chords. Let's take a look at today's do now, number 27 on our region, so a 2-point extended response question. The coordinates of the endpoints of AB are A, -6, -5, and B, 4, 0. Point P is on AB. Determine and state the coordinates of point P such that AP, the ratio of AP to PB is 2 to 3. So we're splitting up the segment in a 2 to 3 ratio. So of course we want to use the grid. So you plot the segment like I already did. And the first step for a question like this is to find the slope of AB. Now you made the segment. Alright, so we're going to go straight out from A to B. We're going to go up 1, 2, 3, 4, 5, and then right 10. That'd be a slope of 5 over 10. But remember, we want to work with the simplified slope. So what would we simplify 5 over 10 to? It'd be 1 over 2. And now we start breaking up the segment with that simplified slope. So up 1, right 2. And now you can see, hey, we have 1, 2, 3, 4, 5 sections, which is great because we have a 2 to 3 ratio that we're looking for. That means 5 total sections. All right, remember in a problem like this also we go left to right. Okay, so we want to go from A, and we're going to go 1, 2 sections worth, and then on the other side we'll have the 3 remaining sections. So really the point in between that would be right here. That would be point P. Remember the problem said to state the coordinates, so P, what point is that? How would I write that as an ordered pair? So from the origin it would be left 2 and then down 3. So -2, -3. That's your coordinate, and you're good to go. Alright, so our aim. What is the relationship between intersecting chords of a circle? So let's remember what chords are. If you look at your parts of the circle, a chord goes from one point on the circle to another point on the circle, and it stays in the interior. It stays on the inside of the circle. So right here, it hits the circle twice. Once, twice. What makes it different than the diameter? Remember, the diameter passes through the center. A chord does not. A chord can go anywhere from one part of the circle to another point on the circle. Does not have to pass through the center. So there's a special relationship when two chords intersect, and then they ask you for an angle, like for example X here. Now a lot of students get, let me change colors for that, make it something a little different. A lot of students get confused thinking that this is a central angle, so they'll say, okay, right, X right here in green, they'll say that that's 70 degrees. It's not a central angle because it's not at the center. Look at the center, point O there. It's not at the center, so it's not the same relationship as the central angle. If you've been following through well with Module 5, you know a central angle is equal to the intercepted arc. So right now, X here, its intercepted arc is BD. However, it's not just equal to BD, once again, because this is not a central angle. Technically, when the chords intersect like this, there's 2 intercepted arcs, and here's why. Because on the other side of X, if we go across from X, those angles are equal. Do we remember what relationship makes those 2 angles equal? Hopefully you're thinking those are vertical angles. Right? Those 2 X's right there, those are vertical angles. They're congruent to each other. So on the other side, we really have another intercepted arc. So on the other side, we have the arc of CA. Alright, so with intersecting chords, we essentially have 2 intercepted arcs. Now how are those formed? Once again, let's just look at the angle, the initial angle, X. See how it opens up, right? It opens up and hits B. It opens up and hits D. Same thing on the other side. Opens up, hits C, opens up, hits A. So that's how you get your intercepted arcs. So there's really, the angles open up and hit arcs. So our intercepted arcs are 70 and 170 degrees. Alright, so now we're in yellow here. Angle formed inside by 2 chords. It's half the sum of the intercepted arcs. So what does that mean? Half the sum. All we need to do to find x here is to add the arcs together, 70 degrees and 170 degrees, and divide that by 2. That's it. Okay? It's not, once again, it's not just, oh, it's 70, oh, it's 170. No, not quite. All right? So that when there's intersecting chords, all right, when there's intersecting chords, there's 2 intercepted arcs we're dealing with. All right? So add the 2 intercepted arcs together, divide it by 2. All right, and for this one, you would end up getting 120 degrees. 70 plus 170 is 240, divided by 2, you get 120. All right, so this is the main rule for today. You can take this rule and go with it. Remember, at any point, pause the video, work on the problems on your own. But this is very, very new, so we're going to go through most of it together, and then I'll leave you some practice problems. Now, this is the main rule, intersecting chords for today, but then, guys, in Module 5, to be honest with you, there's just really a lot of just random rules that aren't like a whole lesson's worth. All right, we don't need to take like a full 43 minutes to go through it. There's just some random rules that need to be mentioned throughout. One of them is an angle inscribed in a semicircle. Now, we did talk about this briefly in one of the other Module 5 lessons, but this is always 90 degrees, this type of angle. Remember, it's inscribed in a semicircle, so this angle, it opens up, hits an arc. This arc that we're dealing with is exactly half of the circle. How do we know that that's half of a circle? Because this is a diameter. See, from X to Z, that's a diameter. So this circle was cut into 2 perfectly equal parts, 2 semicircles. So really, this arc over here is 180 degrees. The inscribed angle, remember the rule for the inscribed angle, that's equal to half of, all right, the intercepted arc. So that's how you get 90 degrees. But memorize this rule, please. Anytime you have an angle that's perfectly inscribed in half of a circle, it's always 90 degrees. And you'll see a problem later on where you're going to need to use that. Always 90 degrees. So this is how it looks, an angle inscribed in a semicircle. And I'll also challenge you to find this in your notes from earlier in Module 5 when we talked about that. Now, another sort of random rule is a tangent radius. Whenever you have a tangent, so let's take a look at AC, that's a tangent. Because it only hits the circle one time, it only perfectly hits the circle at point B there. So whenever you have a tangent and a radius, or really a diameter, all right, when they meet, they're perpendicular to each other. They form right angles, so we have a right angle on this side and a right angle on that side. It's another just good rule to know. You never know when it's randomly going to show up. Okay, so it says a tangent to a circle is perpendicular to the radius at the point of tangency. The point of tangency is just where the tangent hits the circle, which is point B. All right, so you have a tangent here, you have a radius. When they meet, they form right angles. All right. So example 1. In the diagram below of circle O, chords AD and BC intersect at E. The measure of arc AC is 87. They filled that in for you. And the measure of arc BD is 35. All right. So the 2 arcs that they're talking about there. What is the measure? What is the degree measure of angle CEA? So CEA, let's locate it. All right. Remember, that angle is the exact same as right here, BED or DEB, because those are vertical angles, they're congruent. So I just want you thinking about intersecting chords. These are 2 chords that intersect. There's 2 intercepted arcs. Remember, it opens up, right on this side, it opens up, it hits this arc. On this side, it opens up and hits that arc of 35. So that's where this is coming from. Those are the 2 intercepted arcs. So your rule for that, to find the angle formed by those chords intersecting, you take the 2 arcs and you add them together. All right, and then you divide by 2. All right, so 87 and 35 makes 122. Divide that by 2, and you get 61 degrees. Choice 2. Now keep in mind, once you get this 61 and 61, they might also ask you for this angle here. Remember, it would just be a linear pair. So it would be 180 minus the 61. For 119, you don't need this right now. I'm just showing you how other problems could look. You might have had to use this information to say, okay, 61, 61, and this is really 119, 119. Be careful about what angle they're asking you to find, what information they give you. All right, and that's that. So example 2 now. Given the measure of arc GJ is 92 degrees, so let's kind of highlight that. We'll fill in what we got. GJ is 92 degrees, and the measure of arc FH is 104 degrees. Find the measure of angle GKJ. So locate that angle, GKJ, which would be right there. Remember, that's the same angle as that one right there. Those are vertical angles. They're congruent. So there's 2 intercepted arcs that we're dealing with to find it. All right, 92 and 104 divided by 2. That comes to 98 degrees. So in here now we have 98, 98. They're vertical angles, they're equal to each other. And then the 2 angles next to that, they're also asking for in this section over here. Alright, they're asking for every single angle on the interior there. So those angles would be 82. 180 minus 98, just a linear pair. And that's all the angles they asked you for. So 98, 98, and 82, 82. And that's it. So guys, remember, at any point, you know the rule, you can go with it, try it out on your own, or you can watch the video. So example 3, in circle A below, chord BC and diameter DAE intersect at F. So it's the same rule. If it's a chord and a diameter crossing each other, or 2 chords, keep that in mind. Next, so they said if the measure of arc CD is equal to 46 degrees, and the measure of arc DB, alright, DB, now they're telling us this over here, alright, the measure of arc DB is 102 degrees, what is the measure of angle CFE? So CFE is here. Now the tricky part is, what 2 arcs do we really need right now? When there's 2 intersecting chords, or a chord and a diameter like here, remember there's that angle we're looking for. Remember, that's the same thing as that angle there. So what are the 2 arcs we need? So this one opens up top there, opens up and hits the 102. On the other side, we open up here and here, and we're hitting arc CE. Alright, so what we really need here is this arc over here to complete the problem, because it would be CE and 102 are the 2 intercepted arcs. Alright, I'm going to erase this, but we need that arc and that arc there. Those are the 2 intercepted arcs for the angles that they're asking us to find on the interior there. Alright, now we don't have arc CE, but how could we find it? Arc CE. What you need to see here is that we're dealing with a diameter. So from D all the way around to E, what I'm marking in yellow here, how many degrees is that arc in total? Hopefully you're thinking 180 degrees. Why? Because that's half of the circle. So 46, as we go around from D all the way to E, 46 and something is going to make 180 degrees. that something is 134 degrees. So this is kind of where you're using your day one module 5 angle relationships within a circle. Remember, half of the circle is 180 degrees. So the two arcs to find CFE, the two arcs we're going to be using is the 102 degrees and that 134 degrees that we just found. And you divide that by 2, and that gives you, for angle CFE, 118 degrees. Alright, we're going to do one more together. Example 4, in the diagram below of circle O, chords A, B, and CD intersect at E. If the measure of arc AC is 72 degrees, they mark that for us. And the measure of angle AEC, so in the interior there, that's 58. How many degrees are in the measure of arc DB? Alright, so now we're trying to find the arc, so this is a little bit different. Now that 58 on the interior there, remember that's the same thing as here. 58. Those are vertical angles. Vertical angles are congruent. So your setup here, we're finding the arc. We're just going to set up an equation. Remember, the two intercepted arcs right here are 72 and x for the angles on the inside, 58, 58. The two intercepted arcs are 72 and x. So 72 plus x, when you add the two arcs and divide that by 2, that gives you the measure of that 58 degree angle on the interior there. Now, this is a little bit tricky to solve. All right, I don't really want you getting caught up too much in the algebra. Try it by hand, make sure you get the right answer. But I just want to give you something to think about. Remember, this is an equation. Anytime you have an equation, you can throw that into GeoGebra and use the graph to answer the problem as well. So solve it algebraically if you'd like. This would really be 58 over 1 and all that, but I just want to show this to you in GeoGebra as well. So 72 plus x, put it in parentheses, the 72 plus x, 72 plus x, because we want to divide that whole thing by 2. 72 plus x divided by 2 is equal to that 58. Enter. Right, that's exactly as we wrote it. 72 plus x divided by 2 equals 58. And remember, now you just look for your x-intercept, which is 44. Alright, so we get 44. Remember, you can do it algebraically. Just want to show you another way. So you get 44 degrees there. And that answer choice makes sense, right? Well, this arc is smaller than the 72, right? For x here, that arc, dB, it's smaller than 72 for sure. So really your two answer choices that were even possible were 65 and 44. All right, 14 would be too small, 108 too big, and so it had to be between 65 and 44. All right, so this one, example 5, is a tricky one. You're going to try it on your own, but it's asking you to find the angle that's inscribed in a semicircle. So that goes back to, can you find the angle that essentially looks something like this? It doesn't have to be in that exact location, but it's an angle that's inscribed. It's on the circle. It's perfectly inscribed in a semicircle. So I want you to try example 5. See if you can find that. And you get your answer later on. 6, this is a random property from the quadrilateral. Once again, I just want to show you this is all in Module 5. We talked about this random property on the first day, or one of the first days at least. Oh, so this is when we talked about the angle inscribed in a semicircle. And this is the rule, remember, for the quadrilateral. If a quadrilateral is inscribed in a circle, the opposite angles are supplementary. And then you're going to practice one of these from today about the intersecting chords on your own. So try 5, 6, 7. Check back, ask questions throughout the day. I'll also be posting your Delta Math. get a head start on that. That'll be due Thursday as always. Alright, have a wonderful rest of your day, and I'll see you Monday.